Welcome all of you to another video of Maths Made Easy. Now in this video I am going to take up a 10th ICSE topic. Okay, I have uploaded many 10th ICSE topics beforehand also, like quadratic equation, and there are few more you can check in the playlist, but this is one topic I hadn't uploaded till now, so I thought I will upload this because I will go along with the as they teach in the school, in the same method, in the same sequence I shall be going, so that it helps in your every upcoming exam. So now I am going to take up linear inequations. Okay, one chapter which is there in 10th ICSE topic. Okay, so I shall be doing the sums from Selena, but then these days you can follow from RS Agrawal also. The sum type is the same. Okay, I am following Selena publishers. So here I am doing linear inequations. You can follow from RS Agrawal, you can also follow from Das Gupta and Prasad, okay, or Selena or ML Agrawal. So different schools follow different textbook, no problem. You can still understand that topic as I do the sums. Watch the video from the beginning to the end, because my videos always have the different types of sums done. Okay, so just in case I don't finish this video, the entire topic in this video, then there is going to be another video which is going to be linear inequations part 2. This will be part 1 and part 2. So look for linear inequations part 2 in that case. Okay, I shall be finishing the full chapter, and the links will be provided of part 2 will be provided in the description box, so you can take a look at that. Okay, another thing, please subscribe the channel, because if you subscribe, because I shall be uploading many worksheets after this. So and firstly I'll be uploading topic wise worksheet, and then I shall be uploading mixed worksheets to help you with your exams. Okay, so please subscribe the channel in order to get the notifications. Also I would like to tell all of you that the subscription for the channel, it is not a paid channel, so the subscription of the channel is completely free. Okay, so please look for the subscription button and subscribe. At the end of the video also you'll get the subscription button, you can subscribe in the video. Okay, so let us start then. When you were in your lower classes, you had done something like linear equations in 8th standard. Okay, and then you did simultaneous linear equations in 9th standard. Now this is linear inequations, which is slightly different from linear equations. But if you have a fair idea about linear equations, then linear inequations will not be much of a problem. Okay, so first thing, what is the inequality sign? This is the inequality sign. Okay, so it is, this side is greater than, this side is 9 is greater than, okay, 4, and this is, this sign is for greater than equal to. Okay, so when I put like this, it becomes greater than equal to. Okay, it can be either greater than, or also in some cases it can also be equal to. So it won't work for numbers definitely, it is going to work for algebraic expressions, because for certain value of the algebraic expression this side, it becomes equal to this side. That is why we say we use this. This is less than equal to, like that. Okay, and only this is less than. Okay, so let us start with a few sums, and you'll see how easy it is. Okay, there is one minute difference between linear equations and inequations, of course apart from the sign, and that is where you all go wrong. So as I proceed with the video, I shall be talking about that, and you will know that what is that particular thing that we have to keep in mind when we do sums from this chapter. Okay, so let's take the first one. If x belongs to natural number. Now there's a whole lot of symbols that we are going to use. This is belongs to. Okay, if x belongs to natural numbers, then find the solution set of the given inequations. What are the inequations? 5x plus 3 less than equal to 2x plus 18 less than equal to, let me make it very clear, this is less than equal to. Okay, so here is my 5x plus 3 less than equal to 2x plus 18, and they want us not a solution but they want a solution set. Okay, that is because we have lots of algebra here. Why? Because x can take different values and this particular inequation can be satisfied by different values of x. So we need a set of solutions and not one solution. Okay, so x belongs to, now one thing they are being very specific is that x belongs to natural numbers. Now this set N is called the replacement set. This is called the replacement set. Okay, replacements, it is named the replace. So there are different names, you just have to know the names very clearly. So by the end of the video you'll know it anyway. So replacement set is x can take values only from the natural number set, that is 1, 2, 3, 4 counting numbers, and we have to find the solution set. So first thing is we will treat this exactly like a linear equation, means we'll bring all x's to one side. Okay, this is what we were doing for linear equations. Okay, 18 minus 3, that is a 15, and this side is a 3x. Now what we did, 15 by 3, which is a, so x is less than equal to 5. Now till now, did you see any difference between equations and inequations? Okay, till now there is no difference. So let me just continue and I shall be telling you what exactly the thing is that differentiates inequations from linear equations. Okay, so here I have, see, this is x is less than 5. Now what? If x is less than 5, I need the solution set. What is the solution set? Now x belongs to natural numbers. So the solution set is, and you have to give your answer like this, curly bracket, not regular bracket, and then you'll have to write 1, 2, 3, 4 and 5. Yeah, 1, 2, 3, 4 and 5. These are the what? These are the solutions for x belongs to natural numbers replacement set. Why? Because they say x can take any value either equal to 5 because of this line or less than 5. But then we can't take negatives, we can't even take 0 because here x belongs to only natural numbers. Therefore, this is our answer, this is our solution set for this question. Let me do another one very similar. Here is 3x minus 2 less than 19 minus 4x. Now in this question there is no less than equal to, it is only less than. Okay, again we'll bring all the x's to one side. So when the x comes to one side, even in linear equation we were changing the sign, here also we changed the sign. Okay, and then 19 plus 2. Now this is a 7x and this is a 21, x is 3. Okay, and so what is my solution set? My solution set is here x less than 3, 1 and 2. I can't even take 3 because they don't have the less than equal to sign. Hence 1 comma 2 is my answer. Okay, so 1 comma 2 is my solution set. Okay, so now let me, so this is my answer. So till now we didn't see any difference really from between this and between linear equations. We just kept this sign in the middle and we just kept this sign in the middle and we kept doing our sum. Okay, now let us do a few more questions. Here the replacement set is now the set of whole numbers. Okay, and then they are saying solve. When they say solve or they say find the solution set, you can write here solve. It means the same. Solving means find the solution set only. Here they have changed the replacement set to the set of whole numbers. X plus 7 less than equal to 11. Same as before. Same sign copied, 11 minus 7, numbers to one side, that is a 4. Yeah. Till now, I don't see a difference. So x is less than 4. Let me write the solution set. The solution set is how much? It is set whole numbers. So it can take 0. Now that replacement set is whole numbers. 1, 2, 3 and 4. We have to include 4 also because it is less than equal to 4. Okay. Now let me take for the same replacement set. I'll take another question. 18 less than equal to 3x minus 2. Okay. Now this is let's bring the 2 this side and it becomes a 20. That is 3x. Okay. So now what we used to do in linear equations is bring the 3 down. So we bring the 3 down. X is greater than 20 by 3. That means 20 by 3 is how much? 6 and 2 by 3, right? X is greater than 6, 2 by 3. Okay, now I need to write my solution set for this. So what is my solution set for this? Keeping in mind that they are whole numbers. So here again solution set. So I'll have to start with my solution set. X is greater than 6 2/3. Okay, so it greater than equal to, that means it cannot take 6. It is equal to 6 2/3. So the next whole number is 7 and then 8 and then 9 comma dot dot dot, means it goes till infinity. Okay, so this is my solution set for if the replacement set is the set of whole numbers. Okay, so this was one type, this is another type. If the replacement set is the set of real numbers is our next question. If the replacement set is a set of real numbers, then we have to solve minus 4x greater than equal to minus 16. We have to solve for this. Okay, so here x is, we have to, now here this is where it has to be little different. Okay, now look here, had it been only a linear equation, I would have brought the minus 4 down here and then I would have cancelled, and x, it would have been x is greater than equal to 4. That would have been my answer. But here now I am in inequations. Here if I am dividing, this is what I wanted to tell. This is what makes this chapter different from your linear equations chapter. If I am dividing with a negative sign, or even if I am multiplying with a negative sign, when I say minus 4 is being brought that side, it simply means I am dividing with a minus 4 this side and that side. Okay, so instead of saying that, I simply say I am taking the minus 4 that side. So here I am taking, because I have to find the value of x, I am not finding the value of minus x. Solving means find the value of x. If they have told us to solve, it means solve, they told us. Okay, if they have told us to solve, it means finding the value of x and not minus x. So we'll take the minus 4. Now since we have divided with a negative number, hence now see minus 4. Okay, whenever we divide with a minus 4, with a minus negative number, even minus 1, then we'll have to change this sign. It just becomes opposite. Okay, so x is less than equal to 4. Okay, now we need to write the solution set. Okay, now there are two ways of writing solutions in this chapter. One is writing the solution set and another is the number line. Okay, so here I'll have to write the solution set, that is what they ask. So the solution set, how do I write? So real numbers, real numbers are not like, it's not like integers, it's not like whole numbers or natural numbers where you can take only 1, 2, 3, 4. I have to take 1.34, 1.35. So in the number line between 1 and 2, this entire area I have to take. 1, 2 also I have to take, and this entire area, any fraction, not just 1.5, even 1.555, everything is considered as a real number. Okay, so here when I talk about it, when I talk about this, what to do? I have to, I have to take the entire range of numbers which are less than 4. Okay, now real numbers extend from negative infinity to positive infinity. They take the integers, they take the natural numbers, they take the whole numbers, they take everything, and the fractions, everything, rational, irrational, everything comes under real numbers. Okay, so now what to do? We shall just we'll write it in the, when we have to write real number solution set comes in the according to set theory, it comes according to the set builder form. X is such that X, this sign is for such that, belongs to the set of, X belongs to the set of natural numbers. Okay, X is such that X belongs to the set of, real numbers. Okay, and X is less than equal to 4. This is our solution set. We cannot write all the numbers discretely like we write in for other whole numbers or natural numbers set. So we have to write in, this is called set builder form. You must have learned it when you did set theory. So we have to learn to write like this. Okay, so X is such that, double dot is such that X belongs to the set of real numbers and X is less than equal to 4. Now when we say that, it means any value in the real number set, all fractional rational number values will be taken till the number 4 and less than 4, that is in the negative side also. It is not going to stop at 0 or 1. It is just going to continue to the negative side of the number line also. So that is the meaning of this statement. So this is how we write a solution when it comes to the real number replacement set. Okay, so let's do another few sums here. Now this is our next sum for the same question. Again, replacement set is real numbers only. Okay, so we'll bring all the x's to one side. We'll bring all x's to one side with a negative sign, just like linear equations. Okay, and it is no longer less than equal to, it is just greater than 9. Okay, this 5 goes that side, makes a minus 5. Remember, when we are taking this 5, there is a change in sign, but we are not dividing. Okay, so when we do transposition, that is, we take this 5, we are not dividing here. As long as we change plus to minus, minus to plus by going to the other side of the inequation sign, there is no change in this sign. But when we divide with a negative, then there is a change in the sign. So here it is 4 and here the LCM is at 20. So 5x minus 4x, 5x minus 4x, which is x by 20 greater than 4. Okay. So now what should I write? Therefore I should write x is greater than 80, isn't it? X is greater than 80. If x is greater than 80, now how should I write my solution set? My solution set is such that x is such that x belongs to the real numbers set. Okay, and x is greater than 80. That is all. Okay, because I really can't put down one by one numbers. That is, discretely I can't put the numbers. So here is the question. Solve the inequation 12 plus 1 5 by 6 x is less than 5, okay, plus 3x, and x is r. Okay. So this is x belongs to r. Now, here we are going to solve this. Now this inequation I have taken up because it looks little complex. Okay, these come for bigger number of marks. So we'll all x's to one side. First, this is mixed to improper. So this is 11 by 6x minus 3x less than equal to 5 minus 12 minus 7. Okay. Now note that I am not changing the sign anywhere. And then 6 is the LCM, 11x minus this is 18x. Okay, so this is minus 7x and here it is minus 42. Now note one thing here in this sum. I have till now not changed the sign because this was positive. I just took it and multiplied there. Okay, any multiplication it's happening with positive only, no need to change the sign. Now I want the value of x. So I want to divide both sides with a minus 7. So here now I divide and so the sign changes. And when I divide with a minus 7, it becomes a 6. x is greater than 6. How do I write my solution set? X is such that x belongs to real numbers, comma, and x greater than equal to 6. That is my answer. Given x belongs to the set of integers. This is how they will write the questions. They will write the questions in a variety of ways. You need to understand. Find the solution set of, okay, solution set of, find solution set of what? They have given -5. Now note the difference in this inequation. Okay, here, this is the difference in this inequation. Why? There are two inequality signs, twice it has come. Okay, now the confusion starts how to solve this. We'll take one at a time. We'll take this and this. Okay, so -5, this, 2x minus 3. At the moment, I forget about the x plus 2. Okay, so take the numbers to one side, and so here it is 2x, and this is -5 plus 3. This is -2, this is 2x. Yeah, so x is, now I divide with a 2 throughout, so no change in sign. I am not dividing with a negative, so it is a -1. Okay, now I need to take the other one also, 2x minus 3 and x plus 2. Okay, so you can even take this and this, no problem. So here this is 2x minus x, 2 plus 3. Note no changes. Okay, x is less than 5. Okay, so here this is my next inequation. So now my answer has to be made from these two inequations. Okay, so these are the two inequations which will make my answer. So x has to be real numbers, first case. Second, x has to be less than 5, not equal to. X has to be greater than -1. Okay, so what do I do? But 1 minute, it's not real numbers, sorry, it is integers. Okay, so I'll start picking the integers. It is taking -1 is included, so -1, comma, and then 0, comma, 1, 2, 3, 4, and we will not take 5 because they have not used the inequality sign. So since they have used replacement set as integers, we are getting numbers, and we can write a solution set like this, which for real numbers we cannot do. So we have to stop at 4 because this is less than 5, not less than equal to 5. Now here is my next question. X, this time the replacement set is the set of whole numbers. Okay, so see the difference. One we took real numbers, then we took whole numbers, and now I am taking integers, and now whole numbers. Now I'll take this part first, okay, and forget about the other part. This is 3 plus 4x less than 23, and I forget about it. Okay, so here take this 3 this side, it becomes a -3, and the 4x here, that is a -4 and the 4x here. I have to get the value of only x and not -x and all. So I'll divide with a 4. So this becomes a -1. Still no change in sign. Okay, here this is 4x and this is 23 minus 3. That is 20. 4x. X is 20 by 4, which is x is, this is 5. X is less than 5. So my answer has to be made up of these two parts. Together or from these two, I'll make the answer. So here it is the set of whole numbers. It is greater than -1. Okay, we'll start with 0. We can include 0 because it is whole numbers. Then we take 1, 2, 3 and 4, and we'll not include 5 because 5 they don't have less than equal to 5. Okay. So with this we are going to stop here in this video because this video is going a little too long. So what I'll do is I will do it in linear inequations second part. We shall be doing, if you have seen all your number line questions which you are very confused of, we shall be taking up those questions, okay, in the second part of in linear inequations. So look for the link in the description box. You'll get the link of linear equations part 2, okay, and it will be uploaded right after this video. I shall be uploading linear inequations part 2. Okay, then that's it for today. If you have liked the video, do not forget to like, share and subscribe. Bye then.